Let us now take one example on Kolbes electrolysis process. The first example is sodium acetate. Sodium acetate. Okay, everything related to the mechanism I have explained you. We are going to solve one question based on Kolbe electrolysis. Sodium acetate we are going to use in order to prepare the alkane. Okay, so which alkane we will be preparing, that we will look into the mechanism first. Okay, now basically sodium acetate. Now from where the sodium acetate we will be getting? Definitely we will be getting it from acetic acid. Okay, so acetic acid, the formula is CH3 COOH, and if I replace this H with Na, okay, if I replace the H with Na, I will be getting what? I will be getting sodium acetate. Clear? So what will be the reaction, students? It will be CH3 COONA, this is sodium acetate, plus twice of water molecule, this is also twice. Then in the presence of water, okay, electrolysis process is going to take place. Now, how the reaction will be? Over here, I know that this water has H plus and OH minus ions, right? So 2H2O means 2H plus and 2OH minus, isn't it? So over here, what is going to happen? There will be loss of this CO2. Okay, since we have 2 CO2, we will be getting 2 CO2. Okay, there will be loss of 2 carbon dioxide, then Na, and then this OH group. Na will combine with 2 OH group in order to form 2 NaOH, right? And then what we are left with, students? We are left with H plus. Okay, so 2H plus, they will combine to give H2. And then we are left with the major product. And what is the major product over here? CH3. So 2 CH3 we have. Okay, and this CH3 will form a bond with one more CH3. Clear? So basically there is what? There is a bond formation between the carbon-carbon. And I'm going to get this particular structure. Clear? So this is the reaction. Now let us quickly have a look on the mechanism. Now mechanism, we know that very first thing, we know that CH3CONA, it is going to dissociate into CH3COO minus and plus Na plus. So these are the ions we will be getting after dissociation, right? Okay. Now, in this case, this is the negative ion called as anion, whereas we have a positive ion called as cation. Clear? Always remember, very simple trick, very simple concept. Anion, okay, anion will go and get discharged on anode, okay. A stands for anion, A for anode. C is cation and it will go towards a cathode. Clear? Anion is negative charge. This is negative charge. So anode, it should be positive. Cation is positive charge. So cathode, it should be what? It should be positive. Oh, sorry. It should be what? It should be negative. Because opposite, on the opposite electrode, the ions will go and get discharged. Right? Okay. Let us now quickly have a look on the reaction. Now, when I talk about the anode, now anode, since it undergoes oxidation, okay, it undergoes what? Oxidation. Now, what is going to happen, students? There will be loss of electron, okay? Loss of electron, isn't it? Now, at anode, which ion is going to get discharged? As I said, anode is what? It is a positive charge, right? So, positive, towards positive, the negative ions will go. And which are the negative ions? We have CH3, COO minus. Okay, so this is CH3COO minus. It will go towards the anode. And then towards the anode, what is going to happen, students? There will be what? There will be homolytic fission. I mean to say, this bond, okay, from this bond, one electron will go towards CH3COO minus and one electron will be removed. Okay, there will be loss of one electron. So if there is loss of one electron, this acetate ion, okay, when it goes towards the cathode, what is going to happen? This acetate ion, it will give out the electron. Okay, this acetate ion, it will give out the electron. So there is what? Loss. So basically what is going to happen? This CH3COO, it will take up one electron. That is, it will form a free radical and then one electron is being lost. Clear? So this is the first step. Now, when I talk about the cathode, okay, when I talk about cathode, okay, now further, what is going to happen is this CH3, C double bond O and O. Okay, this is the free radical which we have formed in the first step. Now, this particular compound, what is going to happen? There will be homolytic fission over here. I mean to say, one electron will be taken up by this carbon and the other electron will be taken up by this carbon. Okay, now CH3, it is going to form a free radical plus, okay, this C, this carbon and oxygen. Now, carbon, it will take up one electron. And since carbon will take up one electron and oxygen, it has one electron, that is a free radical. There will be what? There will be the formation of a double bond, right? There will be C double bond O. Okay, because already one bond was present and the new additional bond is because of the free radicals. And then this is already present. Okay, this is the second step. Now, if I look into CH3, now this is a free radical and we know that free radicals, they are highly reactive in nature because they are what? They are one electron less deficient. So they need one more electron to get balanced or to get a stable, right? So CH3, what is going to happen? The CH3, it will combine with one more CH3, okay, one more methyl radical. And then it is going to form what? It is going to form CH3 bond CH3. Now, from where we are getting the CH3? Simply, what I can do is, instead of 2 CH3, I can put here 2. Okay. So, if I am putting 2 over here, so everywhere I need to put 2. So, this 2 means I will get it from this particular group if I am having 2 moles of acetate group. Okay. And then this 2 moles of this thing will give me 2 moles of carbon dioxide. Isn't it? So everywhere I need to put what? I need to put 2. Okay. In order to balance the reaction. So this is the entire thing. And then at the anode, which alkane is deposited? It is what? It is alkane. Which alkane it is deposited? It is ethane. Okay. So this is the formation of ethane at the anode. And since it is what? It is a free radical reaction. Always remember, Kolbes, it follows free radical reaction. Now let us talk about cathode. Now cathode, if I look into cathode, it undergoes reduction and reduction means gain of electron, right? Reduction is gain of electron. So gain of electron, and then we know that cathode, it is what? It is a negative charged electrode. And towards this negative, always remember the positive ions will go. Okay. And which are the positive ions we have, students? We have, okay, here if I look into H2O, okay, from here, these were the negative ion. The positive one is Na plus, okay, we have Na plus. Also, we have H plus, okay, we also have H plus. That means we have two positive ions, Na plus and H plus. So, out of these two, okay, out of these two, which one will be going and attacking on the cathode? So that we need to remember. Okay. So for that, always remember, we are going to follow the reduction, or we are going to follow the reducing rule. Okay. Always remember, hydrogen, it is having what? It is having more reduction potential than sodium. Okay. I repeat, hydrogen, it is having what? It is having more reduction potential than sodium. So out of these two, hydrogen is preferred over sodium at the cathode. Okay, I mean to say at the cathode, hydrogen will get reduced. And get reduced means it is going to gain an electron. Okay, so if I need to write down the reaction at cathode, simply what I can do is, I'll write down here, this will be 2H plus, okay, plus electron, or else what we can do is we can simply take H plus 1 electron when it adds, okay, this plus and this minus, it will get cancelled. Okay, so I'm going to get only H. But we know that H, it does not exist stable, okay, in nature. So H, it is what? Hydrogen, it is always stable in its diatomic form. Diatomic form means it should be 2. So if here it is H2, definitely I need to balance the reaction. I need to balance the reaction. And always remember, the electrons which are formed at anode, the same, that many electrons you need to use it at cathode. Clear? Okay. So this is the reaction at cathode, and I can see hydrogen gas is released. Then what will happen to Na? Okay. Now what is going to happen to Na? Now this Na which is left, okay, this Na which is left, this Na, it will react with OH. Okay, it is going to react with OH, and I am going to get what? NaOH. Okay, so Na, I'll write down here. Na, it is reacting with OH, and then I will be getting NaOH because Na is plus, OH is minus. Clear? And since there is formation of NaOH, always remember, students, the resulting solution, it is what? It is basic in nature. Okay, and since it is basic in nature, definitely the pH will be very, very high. Because we know that basic solutions, they have pH more than 7, right? Okay, so this is the entire thing. What we have studied, at the anode, there will be formation of ethane, whereas at cathode, there is what? There is the formation of hydrogen gas. Okay, so these are the anodic and cathodic reaction for sodium acetate. So everything we have studied about sodium acetate. Clear? Okay, now quickly we are going to understand the key points for Kolbes electrolysis, and then we are going to solve more and more questions on the same topic. Okay, so quickly we will have a look on the key points. Now for Kolbes electrolysis, what all points we have studied, students? Kolbes reaction, it involves electrolysis of carboxylic acid salts, then alkane formation, okay, by Kolbes electrolysis, there is formation of alkane through decarboxylative, okay, decarboxylation takes place, and then there is dimerization. Dimerization means when two free radicals, they combine together to form the corresponding alkane, okay. Then the tricks are, whenever you come across a question based on Kolbes, you need to think the radicals. Okay, you need to what? Firstly, you need to identify which free radicals can be formed. Okay, the second important trick is remove CO2 from COOH group. Okay, you're going to remove since it is decarboxylation. And then the radicals which you are going to identify, or the radicals which are going to form, they are going to couple among themselves. Okay, couple means they are going to form a bond. Okay, and then you will be getting alkane. And always remember, students, we are going to prepare symmetrical alkanes through this reaction. Okay, through this process. Symmetrical means even number of carbon containing alkanes. And lastly, very important, we cannot prepare methane through this process. Okay, through this electrolysis, we cannot prepare methane. Why we cannot prepare methane? Suppose if I have your CH4, this is the structure of methane, right? Now what we have studied, when two radicals, when they combine, okay, when two radicals they combine, I will be getting what? Carbon and carbon bond. So what, very simple, the first member or the smallest free radical is the methyl group. So definitely if I have one methyl, there should be one more methyl group, and then there will be coupling. So in order to get a CH4, there should be what? So I cannot prepare a CH4. Remember, I cannot prepare CH4 through this process. Of course, there are other processes wherein I can prepare methane. Okay, but through this process, I cannot prepare. Is that clear? So I'll explain more and more examples, application, especially the application-based examples I will be solving in the next lecture. So keep watching all the lectures, and I'll see you in the next lecture.